The cross section of a railway tunnel in Switzerland, which is one of the longest in the world, is a square surmounted by a semicircle as shown below. The tunnel is about 57 kilometers long. Acrylic paint is used to paint its walls and roof. The paint has a spreading rate of 10 square meters per liter. How many liters of paint to the nearest liter is needed to paint the tunnel? Alright, so let's take the data down. Here I have redrawn the cross section. So basically what we have is a square 7 meters on which there is a semicircle. Okay, now this is the solid part, right? This dotted part is only for our understanding that this is basically a square. Alright, so this solid part all the way here is the wall and this is the ground. Alright, so this is 7 meters. If this is the semicircle, let's say this is the center O, and since this is a square, the diameter is going to be 7 meters as well. Therefore, the radius here, let's call it R, is going to be 3.5 meters or 7 by 2 meters. The tunnel itself is 57 kilometers long, and for the time being, we'll assume that it is straight. Alright, so now with this cross section, when you extend the cross section to get the shape, this is the shape that you are going to get. Now we need to find how much paint is required to paint the walls as well as the roof. That is, leaving the ground, everything else is being painted. So what will it comprise of? If you see from here till 7, you have one side of the square, and that side is being extended along the cross section, so that becomes one long rectangle, which is one of the walls of the tunnel. And an identical wall is right opposite it, right? Again, another side of the square. Now if I want to find the area of this, it is simply going to be 7 meters, which is the length, right? Let's call this side L. Okay, so in terms of symbols, it's just going to be L times, let's say the length of the tunnel is capital L. L times capital L. And there are two such walls, so 2 times. So that's 2 times 7 meters times 57 kilometers. I'll make the units uniform in the next step. Now, once I've got the walls, the only thing left is the roof, right? Now in the roof, what you have to do is, you have to realize that this is basically half of a cylinder, is it not? If the whole thing was a circle and you extended it, it would have become a cylinder. So the roof is half of a cylinder. So what we have to find is the curved surface area of this half cylinder. What is the formula for the curved surface area of a full cylinder? 2 pi r h. So in this case, it's going to be just pi, the radius is r, and height h. Now h here happens to be the length of the tunnel, which is capital L. So this is your total surface area A, and let me substitute the values. So I'll get 22 by 7. Radius is 3.5, which can also be written as 7 by 2. Length is 57 kilometers. Now what I'll do is, I'll take out 57 kilometers common, and before going to the next step, I'll also cancel 7 and 7 and 2 and 22. So I'll essentially get 2 times 7 meters plus 11 meters into 57 kilometers into 57 kilometers, which is 57,000 meters. So this is 14 plus 11, 25. This is not decimal, remember, this is multiplication. So 14 plus 11 is 25. 25 times 57,000 square meters is the total area. Now, it's given that the spreading rate of the acrylic paint is 10 square meters for 1 liter, right? So 1 liter is going to take care of 10 square meters. And how many square meters we have? Plenty, right? So how many liters of what volume of paint is required? That will be the total area A divided by 10 square meters. Is it not? So we just do 25 times 57,000 by 10. Now this 0 cancels, and I always like to convert 25 to 100 by 4. So let me cancel this. 4 ones are 4, 4 fours are 16, 4 twos are 8, 4 fives are 20. So this comes to 142500 liters of paint, right? That's 1,42,500 liters of paint to paint the entire tunnel. That's your final answer.